Okay, last subtopic, which is on power. So for this case, you have to be able to define and use average power and instantaneous power. So what is power? Power is defined as the rate at which work is done, or can also be described as rate at which energy is transformed from one type to another. So it is a scalar quantity with the SI unit of watt ataupun joule per second, tapi kamu tulis watt je, W. So for practical purposes, a larger unit is often used, which is horsepower. Usually kamu akan dengar ni di aircon lah, berapa horsepower, 1.5 kah, 1 horsepower kah, gitu. So power actually tells you how fast work is being done. Itulah dia over dengan, itulah formula dia over time, gitulah. Okay, so it is telling us how fast work is done ataupun energy is transferred. So the rate of which work is done might not be constant lah. So we have the term average power. So average power is defined as the rate at which the energy is being transformed lah. So average power is just delta W over delta T, ataupun kamu boleh ataupun delta E, which is energy over delta T. That is the average power. Instantaneous power pula, it is the rate at which work is done might not be constant. So this is the formula. In mechanics pula, instantaneous power can also be expressed in terms of force and velocity lah. So the force di sini yang dia talk about is a constant force lah. Force, constant force. Okay, now let's try to solve example number 5 lah. Our last example for chapter 4. An object of mass 2 kilogram moves at a constant speed of 5 meter per second up a plane inclined at 30 degree to the horizontal. The constant frictional force acting on the object is 4 Newton. Di sini dia bagi kita frictional force. Dia ada bagi unit lagi Newton. Yang hari tu kamu cakap 0.3 tu pula friction force. No, friction force mestilah ada Newton. Sekarang ni ini adalah coefficient. Okay, so let's try to draw this. Okay, so incline at an angle of 30 degree. Lepas tu, it is moving at a constant speed. So just going here lah. So this is the constant speed. So tiada acceleration. So this is the V lah. Frictional force acting on the object. So ada friction. Let me just draw the free body diagram dulu. Okay, so that is like this. So kita akan ada weight force. And then we have the normal force ataupun the reaction force. And then it has a friction force opposing the opposing the motion. That is the friction. And what else? Do we have any external forces? No. Okay, so that should be it. And this is the y component. So 30 degree is here. And then we have the normal force. mg, this is the friction. Kinetic ka ni? It is moving. Yeah, kinetic lah. So now we have to calculate the rate of work done against the gravitational force. Macam tak perlu je pun lukis ano ni? Lukis free body diagram. Do we really need it? It's okay. Let's just solve it. Okay, so the rate of work done. So P is equal to delta W over delta T. So the work done that we are looking at is the apa tu nama dia? It is the what is it? Gravitational force, which is the weight lah. So that is mg s cos theta over delta T. So berapa nilai delta T? Nilai T. Nilai T kita tidak. But we can use the speed punya nilai, which is, we can use the value of the velocity, which is 5 meter per second. Remember, velocity is equal to displacement over time, so that is 5 meter per second. So what we can do is we can extract that S over T. So we can let that equal to V. Gitu. Wow, smart. We are smart, everybody. Okay, so berapa nilai theta tu? Theta tu, perlu je lah. So displacement is like this. Ni your direction of S. So berapa angle from this displacement and the weight? So that is gitu. So berapa tu? Dapat 90 plus 30. So that is 120 degree lah. So M is 9.81 cos 120 degree. Velocity is 5. So dapat power for the gravitational force to be equal to berapa? It is equal to negative 49.1. Negative 49.1 watt. Okay? Okay. Question B, against the frictional force pula. Salah. Power against the frictional force, that is delta W over delta T. Kita buat benda yang sama juga, cuma mg tu dia jadi friction. Boleh kami terus letak di sini ni untuk semua lah. So F net V cos theta. Okay, Miss buat ambil dia dari sini ni sekarang. Lepas so kita buat macam tadi tu. So net is friction times velocity cos theta. So what is your value of friction sekarang ni? Given kan? 4 Newton ke tadi? Yeah, given. So that is 5 pula. 4, 5 cos berapa? Theta. So this is displacement punya arrowhead. This is the arrowhead for friction. So this is 180 degree. So dapat jawapan dia negative 20 watt. Okay, lepas tu kita perlu apa pula? Kita perlu calculate the power supplied to the object. Okay, so power supplied to the object ni, formula dia is just the addition of the two lah. Okay, so power supplied is equal to the power loss against gravitational force. No, kamu just letak P, power gravitational force dengan power friction, kinetic friction. So that is negative 49.1 plus okay. So work done is not, untuk negative tu kamu TP include, it's just telling you is it done by the system ataupun on the system. So tambahlah dengan 20, so dapatlah 69.1 watt. So that is how much power is being supplied to this object lah. Okay, so that is our final example, and that is the end of our chapter 4.